Hi everyone! In this video I'm going to show you how to describe segments in relation to the functions that bound them. On this picture we can see the xy plane and two arbitrary functions, function f of x and then function g of x. I'm going to start by picking an arbitrary value on the x-axis that I'm going to call x1. The arbitrary value means that I just randomly picked a spot on the x-axis, and what I will show next will work no matter what value x1 takes. Now let's consider a point on the graph of the function f of x such that its x-coordinate is that arbitrary value x1. Well, the question is, what's going to be the y-coordinate of that point? We learned that when we know the x value, to find the y value of the function, we just simply have to take that x value and plug it into the function. All that can be written using function notation. So if I write f of x1, again, that means that I am plugging in x1 into the function f, and by doing so, I'm determining the corresponding y value. Okay, so if that is the y-coordinate of that point, that means that the point corresponds to that number on the y-axis. So if I project it to the y-axis, it's going to hit the number that is f of x1. And here's the question. How do I describe the length of the segment that stretches from the x-axis to the graph of the function f of x? Well, to figure this out, I'm going to observe the following. The distance from the origin to the number that I'm calling in general f of x1 on the y-axis. Well, it is f of x1. If you're a little bit confused about that, then think this way. If I imagine that that number is, let's say, 5, well, how far is 5 from 0, or what's the distance from 0 to 5? Well, it is 5, right? So I'm doing the same thing just in general. So distance from 0 to f of x1 is f of x1. But if that's what it is, then I can see that my red segment has exactly the same length, right? Well, that means that the length of this segment is f of x1 as well. So it means that in general, to find the length of segment like that, I have to take the value of x at which the segment is positioned on the x-axis and plug that into the function f. How about I choose a different arbitrary value and let me call it x2. Then how do I describe the length of the segment that stretches from the x-axis to the graph of the function g? I hope you can see the analogy and realize that in this case, the length of the segment is going to be g of x2. So its length depends on where it's positioned on the x-axis. Finally, I'm going to pick the third arbitrary x value. I'm going to call it x3. And this time, I'm interested to know how to describe segment that between graphs of functions f and g, like this. And this is how we're going to think about it. We know that the segment that stretches from the x-axis to the graph of the function f has length f of x3, right? But this is not the segment we need. Our segment, the blue one, is much shorter. Well, how much shorter? Well, it's shorter by this length, right? But what is that length? That's the length of the segment that stretches from the x-axis to the graph of the function g. And we'll really figure out that in this case, its length is going to be described by g of x3. So this means that to find or to describe the length of this blue segment, I have to take the longer one, which is f of x3, and subtract that extra distance, which is g of x3. And when we come across a situation like that, when we have to find or describe length of a segment in between two functions, a lot of times we say that, well, you have to take the top function, evaluated at x, and subtract the bottom function, evaluated at x. And before we move on, I would like to make a quick note. The reason I use the subscripts x1, x2, and x3 just because I'm showing different cases on the same picture, and it would be confusing if I call them all x. But when you're dealing only with one of those three cases, you would not have that subscript and everything would change just to x. Then I would say that the length of this arbitrary red segment is expressed by f of x. The length of this green arbitrary segment is expressed by g of x. And then the length of this blue arbitrary segment is expressed by f of x minus g of x. Now let's try the following. We're given a function, this time it's a specific function. It's y equals x cubed. And my goal is to describe these two red segments. One is vertical and one is horizontal. Now to continue with what we just learned, I'm going to say that this vertical segment is placed at some arbitrary x value. So I'm ignoring the fact that I do have the actual numbers now on the x and y axis. I'm still trying to describe this all in general. So this vertical segment is positioned at some arbitrary x value. Then what is its length? Well, based on what we just learned, its length is going to be the value of the function, or f of x. You may be questioning where that f came from. Well, we know that the function notation f of x is just the alternative way of writing y. So this given function y equals x cubed, I can rewrite it as f of x equals x cubed. So that means that the length of the vertical axis is f of x or x cubed. Now, once again, this is the general way to describe any vertical segment that stretches from the horizontal axis, from the x-axis, to the graph of this function. In other words, tell me where you position the segment, I can tell you how long it's going to be. But what is the length of this horizontal segment? So this is how you want to think about it. I know that from the origin to this place where I'm saying I have x is x units. So this distance is x units. Let's say if that x was equal to 1.5, then, well, from 0 to 1.5 is 1.5 units, right? So from 0 to x is x units. But isn't it the same distance as from here to here? Well, it is, which means that the length of that segment is described by simply x. So that would be the way to describe these two segments. One is vertical, one is horizontal. And everything, as you can see, is expressed in terms of x. Guess what? Sometimes, depending on the problem that we're trying to approach, we have to express everything in terms of variable y, not variable x. Let's see how those two same segments can be described, but in terms of variable y. Okay, so now I have two cases, right? That was the first case when we express everything in terms of x, and now we'll try to do the same thing, but in terms of y. Since now I'm using variable y, my story should be told with respect to y, and that means that my story should begin this way. Well, I constructed a segment at some arbitrary y value. That means that I'm referring now to this horizontal segment. So how do I describe this two? I'm going to start with the one that makes the most sense at this point. And this is what I'm talking about. Well, if this arbitrary place on the y-axis is at some kind of value, y, that means that distance from 0 to that place is y units. Well, and if this distance is y units, well, that means that this distance is also y units, right? So the vertical segment in this case is expressed by y. How about this horizontal segment? Well, here we use similar ideas before. We're saying that this segment stretches from the y-axis to the graph of the function. That means that its length is going to be value of the function at y. And that means that its length depends on y. If it depends on y, it means that function has to be expressed in such form that is function of y, not function of x. And to obtain that, we're gonna need to rewrite the function so that it's, again, in terms of y. To do that, I'll just simply have to get x by itself. So right now, y is by itself, and this function is in terms of x. Well, once I get x by itself, it's going to be a function in terms of y. To get x by itself, I simply have to take cube root on each side. So that means that x equals cube root of y. And now we are looking at the exactly same function. The function itself hasn't changed. It's just the way we express it changed. So once we change this function in terms of variable y, now we can express this horizontal segment and say that its length is cube root of y, or defined by cube root of y. Tell me what y is, and I will tell you how long the segment is. And as I move up or down along the y-axis, I can see that I will be obtaining different segments of different length, but again, their position along the y-axis can be determined by plugging that y value into cube root of y. So let me summarize this. When you're trying to describe segments associated with different functions, the first thing that you need to determine what variable you're using. And again, depending on different problems that you do, you might have a need to express it in terms of x or in terms of y. And once you made up your mind, once you determined what variable you're using, then these two examples given to you side by side give you an idea of how vertical and horizontal segments should be described.